So I'm offering my regrets from my collaborator, David McConville, who was the original speaker for this session. He's out in Montreal, where a collaborator of his just recently passed away. And so when he asked me 2 days ago if I would come to this conference, I thought, great. I'm just coming out of maternity leave. I've been a stay-at-home mom with my 3-year-old son, and I thought this would be a great opportunity for me to hear about data that's coming online, projects and tools. And then he said, but you have to present. I was like, okay. So this is my first foray back, and so please deal with me if I'm not too eloquent or together as much. But what I'd like to do is tell you a story about how I went basically from a GIS technician to a production coordinator of this national environmental literacy project that employed immersive visualization technologies through planetariums to create public engagements and to connect communities with regional environmental change issues. But I'm going to give you this context as an end user of a lot of the data and the services that you guys are generating. And that informal science centers really are an opportunity and a place where a lot of your information, your stories can be told. So I'll give you some examples of the challenges that I've experienced throughout this time and share with you some of the visualization experiments we did at the Academy, and then talk about some of the Worldviews Network's programs that we did, just with 2 examples, and we'll see if there's time while you guys are eating, nobody falls asleep, to get to conclusions. Is that working here? All right. So data visualization, it's a big topic. Everybody's talking about it, and I thought, should I make a talk about data visualization? And really, we've all been visualizing data, all of us, people visualizing the environmental information. But really, I thought this quote was interesting, that if we're going to have a new connection to the environment, it will have to happen in individual hearts and souls. The artist can help us fall in love with the earth again. So you could replace artist with the human, the facilitator, the educator. We can have all these really great visualization projects and products, but if they're not put in the right context, it's just more information, it's just more stuff. So some of the data challenges that I kind of identified while I was preparing this talk, and we'll hear a lot about it in different instances from other talks here, but for me, the accessibility, integration, design is a really important challenge in serving data, managing data, and then telling stories about data. And pace, keeping up pace with, oops, sorry. I'm going through my own slides, sorry about that. That's the planetarium. Here we go. The data challenges. Keeping pace with technology versus scientific discovery, how these tools affect storytelling, and the most important is message and audience. So I worked at the California Academy of Sciences for 8 years, and it was kind of like this mini incubator where there is a research division there that has over 25 million specimen collections, researchers that are doing evolutionary inquiries, support staff, scientists, and then this wonderful public floor where exhibits, aquarium, planetarium, living roof is a nexus of creativity and discussion and dialogue that can happen within the area. But the raw materials that I worked with primarily were the specimen collections. And natural history museums, as you guys, many of you know, are really maintain the records of what occurs where on this planet. And that there are international consortiums like GBIF that are integrating this data and serving it online. Sorry, I'm going to go back one. But the exciting thing is what we can do with these historical collections once they are digitized. Sorry, I'm getting lost in my notes versus what's going on here. As you can see, there's over 440 million occurrence records, and 375 million are actually georeferenced that have lat-long coordinates. So there's all this information of what occurred in the past, what occurs now, but we can only get to a certain amount of it. and those come with uncertainties. So I worked in a research lab called the Center for Applied Biodiversity Research. And it was run by Dr. Healy Hamilton, who was an evolutionary biologist, and the staff and students had skills in remote sensing, GIS, climate modeling, distribution modeling, and I was the visualization and outreach program manager, and so it was my job to go through those data sets, those results, and share it with our museum audiences as well as our collaborators and scientific colleagues. So some of the examples of the work that I did was, retrospective georeferencing, the problems of standardization and data integration and dissemination. There's increased accessibility of these current and historical collections data, but integrating these databases from these participating institutions is a very laborious process. Oops. So training people in how to find a lat long, for a historical locality that's at 5 miles northeast of Blind Man's Bluff, has all kinds of uncertainties with it, but there's wonderful groups that were putting together protocols and serving that data online, which then daylighted some of these collections for more applications. So with that, we could take these occurrence data and work with the scientists in the research division to produce predictive distribution models to see how temperature and precipitation might support genetic research. And then one of the things that I thought was funny from the talk earlier was web applications. We did web mapping in 2005 here, where we integrated specimen data from biodiversity surveys in China. We served it on ArcIMS, and the funding was over, funding ended, and then all these explosion in web mapping applications just came on the scene, and it was like, well, we made it, funding ended, and then it became obsolete. So that was a big lesson. But as time continued, increased data sets came online, and we were able to start to forecast the effects of climate change on biodiversity. So finding these resources and tools, I went to lots of data portals. My colleagues dealt with all kinds of interoperability issues and modeling, and each of these aspects, the taxonomy, the environmental conditions, high-resolution geographic information, the global circulation models that were released. This is actually all from the the IPCC fourth assessment report. They're all coming online, but they all had a lot of issues that we had to deal with for synthetic mapping and modeling. But downscaling these global circulation models meant that we could start to tell stories about these global environmental processes down to a scale where resource managers, different stakeholders actually could use it. So Dr. Hamilton and her lab are still working on these issues today, and they're doing some pretty cool stuff. So some of the examples back in 2000, I guess this would be 2008, is we could start to combine species occurrence data from iconic species that people know and potentially care about, like the wolverine. He's one of my favorite. They're pretty badass. We started to do these ensemble models, and we could see that depending on which scenario, the fate of these species could go either way. So in 2090, under the pessimistic scenario, wolverine is completely extirpated from the United States. But if the optimistic scenario, there are some refugia, and they happen to be in the national parks like Yosemite and Yellowstone. So it kind of opened our lab up to working with NGOs and nonprofits that needed this information to help them with their land acquisition initiatives and climate change adaptation plans. It also opened us up to media. People wanted to see this information. They wanted to hear about it. So KQED And our lab partnered on a series of educational media, videos, and curriculum for 4th to 8th grade teachers. But then the experimentation continued. We worked with Save the Redwoods League to look at mapping historic and current redwood, coast redwood range, and then projected into the future. And the results that we got were pretty striking. Unfortunately, it's too dark in here to really, or it's kind of light in here to really see the results. But basically, or maybe we can start the video, actually. That would be better. Let's see if this will work. So we ended up partnering with the visualization studio in the Morrison Planetarium, where there are videographers and graphics and visualization specialists that could bring this data into a software system called UniView, which is the software system that's being used in the Morrison Planetarium. And as we did this simulation, we could see that under the A2 pessimistic scenario, coast redwood range gets fragmented, it's shifting, it's shrinking, and it's moving north. And this is a pretty big story. I mean, this is something that is important to Californians here, that by 2090, end of century, redwoods would be gone from the Bay Area and from Santa Cruz. So we started thinking, and we thought, could we partner with the Morrison Planetarium, the visualization studio, and see if we can actually get these data sets, these GIS-based data sets, into UniView to be able to see this in an immersive environment in the dome. Let's see. So the Morrison, I don't know if has anybody been to the Morrison Planetarium, the California Academy of Sciences? It's pretty cool. It's the biggest dome in the world, all digital dome in the world. And it runs off of 6 projectors. It's pretty heavy stuff. But the visualization studio and the director, Dr. Ryan Wyatt, wanted to see if we could figure out how to get these data sets to talk to each other. And at the time, it was just around the COP15 talks in Copenhagen, and Dr. Hamilton was going to be there to present. And we thought, could we actually do a simulcast from her hotel into the dome during a nightlife event and have these data, the kind of simulation that I just showed you in the dome, and have a facilitated conversation with the scientist who was actually in Copenhagen. And it was kind of crazy. It was definitely janky, but it worked. And it spurred the next project, which we got a NOAA grant, environmental literacy grant, for 3 years to test this out with a whole network of scientists and educators and visualization specialists to come up with best practices, to create a community of practice around immersive visualization technologies, and to really connect people with these large global issues down to a regional scale. So these are some of our collaborators. Let's see. They're located across the country. And my job really was to coordinate a new live show and public engagement every 3 months. So it was a pretty crazy, grueling process. It's one thing to make a live planetarium show, a production, and it's another thing to have like a community engagement around it. So it was kind of trial by fire. But the deliverables were, we were to create a library of these immersive visualization story templates. So each region we would have a number of stories, and we could work with the director at the time to come up with those stories. And then that way they could actually use the data sets in future programs and projects within their domes. We created a professional development program and training in Earth Systems literacy with those directors and educators. And then we had quarterly bioregional community dialogues is what we called, which were those community events. And then, of course, we had research and evaluation to see what's working and what wasn't working. So we had target audiences, and this is an important thing. We had network partners, which is the core group of planetarium educators and scientists that were working in our partner science institutions. And then we had their public audiences that we assumed would come to the events. But then we soon, in certain instances, we had regional stakeholders, and we may have so many regional stakeholders that it kind of required a private screening of itself. And so that became almost like our third unofficial audience. But the interesting thing about the tools with UniView and with our guiding principles is that we were able to go from the cosmic down to the bioregional. We could cross time, scale, and even spectral scales. All of our programs were driven by a framework, climate literacy framework, planetary boundaries, the conditions of life. We didn't want to just spew information to our audiences. We wanted to go at it in an integrative kind of way. And this is a new approach to planetarium programming at the time. These are educators that are trained in astronomy, and here we are talking about Earth system sciences and Earth issues. So I wanted to give you an example of the Valley Oaks project. Oh, sorry. I'm totally going ahead of myself, aren't I? I'm really sorry about that. Here we go. So one of the things we were thinking about is how can we connect the Academy of Sciences informal science institution with the research that's going on right here, right now in the Bay Area. And we partnered with SFEI, which, thanks to the organizers here, I'm sure many of you know about SFEI. It's an environmental research organization, and we worked with Robin Grossinger from the Historical Ecology Program and Chuck Striplin, who's an environmental scientist and a tribal member of the Amamutsin Ohlone. And he's really a force in indigenous environmental issues all over the state. And through conversations, we learned that SFEI has all of this incredible information, all of this data, but they don't necessarily have the outreach capacity. So our goal is, could we build awareness of the regional impacts of climate change and land use on an iconic species in a landscape that people are familiar with and care about? And can we connect the museum with regional stakeholders and try to be a catalyst for awareness and for action? So we had lots of storyboarding processes or storyboarding sessions, and it was really hard to find, to go through their data sets and figure out where is there a place where there's a continuation of data that can tell a story from past, present, future, from different scales, all in 30 minutes. Can we do that? And so we landed on, we teased out all kinds of options, and we really landed on the Napa Valley watershed and this beautiful iconic species, the valley oak, which is one of the oldest, it's an endemic species, and it's one of the oldest living species, tree species here, and it just represents an incredible story. So iteration after iteration, I wanted to also mention that we created an advisory group that was essential to this production, and that was made up of indigenous elders, council members, the visualization team from the Academy, academics, people from the planning and state agencies, and they were really essential in helping us with crafting our story, and they really were part of the whole production. So we had to create a GIS inventory of where we could get all of this information. And we had interns, we were going through all these data portals, and I'm kind of shy to say that we ended up consolidating it all into a Google Doc that we could all share. But it was enough that we could cross-reference it and tease it out. And our advisors also helped with storyboarding, and we had to go through, each scale, like at the global scale, where are the data sets that we can talk about trees and how important trees are? What are the ecosystem services of trees? But then we also wanted to bring in other perspectives on these ecosystems, and bringing in the native cosmologies and bringing in native land use ethic, as well as the idea that humans were never a part of these ecosystems. They've always been a part of it. They've always been actively managing it, and bringing people back into these landscapes is what will ensure their resilience over time. So some of the examples of the data sets that we brought in were SFEI's wonderful historical information about valley oak ecosystems, to show, to take our audiences through a journey of the Napa Valley, to see like what were the components of a healthy ecosystem, and then what happened over time. And what was really cool is we could stream in through WMS servers aerial photography that was pretty recent. So we could actually do these stepping stones over time into the planetarium and have this conversation. And then we wanted to go even deeper and show a persistent region where there are 300-year-old oak trees in this oak knoll. And we went out there with our kids and with Tim Horn, who takes beautiful photography that we could also bring into the planetarium, where in the show we could actually drop down and look all around at this remnant community, and then layer in a historical photo that was taken in a similar way, and just see the differences over time. And we went through future scenarios, and this is where all of our experimentation and data integration from the past blended together into being able to show, to talk about a concept of re-oaking, which is bringing the oaks back into the landscape through restoration efforts or through city planning efforts. And where would we put those based on a changing climate in the future? Where would be the best places? And so these are just demonstration model results, but as we zoomed into these model results, we could actually show where there are areas that will be persistent over time in the future. And that's kind of a message of hope. A lot of climate change messaging is very scary. It's very politicized, and this is more to just talk about the species and persistence and things that people can do now to ensure resilience in the future. So our event, I'm sorry these photos are not showing up very well. This is another lesson. If you ever host an event, do not take your own photos. Have somebody else take the photos for you. So that way you can actually have good photos afterwards. So at the California Academy of Sciences, they have an after-hours event called Nightlife that happens weekly. And we kind of took over Nightlife that night, and we ended up having 2 screenings. One was for all the regional stakeholders and networks that SFEI brought to us. There were so many that we realized we had to have a whole other show. And then another show screening that was for our general over 21 audience that would come to the Academy and drink and have a good time. So we had 2 very different kinds of audiences, and we were interested early on in this project to see what would be the feedback from the same show with 2 audiences. We had wonderful representation from the tribal communities, local tribal communities that most had never come to the museum before, would never think to come to the museum. And they were impressed that they were saying that their story was actually on the dome, and that was really exciting for them to see that. And also for others in the audience to see, like, these people are still here, they're still working the landscape, they're still active members. And we even had a woman make acorn cakelets as a survey incentive for our audiences to do the surveys. She made these acorn cakes, and we hosted a facilitated dialogue afterwards. And so the evaluations are just coming online right now, so I don't have anything too concrete, and you don't need to read all of this, except that the differences between those 2 audience groups was pretty significant, in that the regional stakeholders, the people who are actively involved in conservation of valley oak ecosystems, they wanted more information. They liked the visuals, they thought it was great, but they wanted more information. They wanted things to go more in depth, whereas the nightlife audience members, they wanted better graphics. So it was like it depends on what you want to do. That really is something to think about when you're crafting a visual product and story. So it'll be interesting to see how that comes about in the next year. Those will come online. And then we disseminated all of the storyboards. We are disseminating with data sets and all the resources that we created to all the regional partners, as well as the UniView modules, so they can use it in their own educational programs after the big event. And what was interesting is to get the GIS files into UniView required us to create a whole new production pipeline, but it resulted in having KMZ and KML files of all the data sets that we used, which can also be used in Google Earth. We also created a website for the public where people could check out links to the NGOs, resources, videos, all pertaining to the themes that were brought up in that particular event's production. So back to the KMZ and KML stuff, we thought, well, wait a minute. Why don't we see what we can do to take these stories even further and bring them to the desktop instead of expecting people to come to the museum? And so we got a grant by Google Earth Outreach to take the Denver Museum of Nature and Science's story about water and do a Google Earth fly-through movie, which is an 8-minute movie telling that story, obviously not from the cosmic, but from the global down to the regional and back again. And then we did an interactive tour as well, where people can download the whole KMZ tour file and zoom around and look at some of the information in more depth at their own pace. We worked with a developer in Germany called Visiomundo, and that was an incredible learning experience for myself, working from GIS to live planetarium production to Google Earth platforms. Just trying to go cross-platform was a pretty crazy experience. So, in conclusion, the challenge of visualizing environmental data is really an idea catalyst, I think, in that we can get people to work together across disciplines. If we can do that early on in the project life cycle, who knows what kind of results you could create or what kind of interactions you can do. I'd be excited to see this community connect with the creative coding and design groups that are doing a lot of really innovative stuff, but they're visualizing Twitter interactions and Facebook interactions, and it's like there's all this information here that could be tapped, and we are really at the forefront of that innovation. The challenges are pretty obvious. Figuring out what your message is versus what the data can say. It was very hard to weave everything down into 30 minutes from Valley Oaks, from the past to the present to the future and back again. Scale, complexity, and clarity of the data. Cultural values that people come to. It's a big topic in climate change visualization. And knowing your audience, it's been brought up before this morning, so that's a big one I'd like to reiterate. And then the importance of the human connection, interactivity, and context. We have to appeal to people's hearts if we want to make an impact. So these are my thank yous, and if you'd like to look up the Worldview's website, the link's on the bottom there, and you can email me at the bottom right there too. Thank you very much.
Thank you very much, Lindsay. We do have time for